The first problem we're going to look at, this is from your homework over the weekend. Okay, it's number 43. The problem starts out, you have a dock here. Okay, that two boats leave the dock exactly at the same time, traveling in exactly the same speed. They both travel for 25 miles. Okay, the first one has a bearing of 42 degrees, 30 minutes. The other one has a bearing of 52 degrees, 12 minutes. Let me stop for a minute and describe bearings to you. Okay, bearings are a lot like our regular angle measurements. But instead of starting at the positive x-axis at 0, bearings go straight up north at 0 degrees. Right? If a boat headed in that direction, then that's bearing 90 degrees. It goes around clockwise. Bearings are a little bit different. It's a different orientation, and they go clockwise rather than counterclockwise. I don't need you to describe that. I need you to know what when they say bearings, it means the angle at hand is different than you would draw it if it was just a regular 90-degree angle. Okay? So if you went down here, that direction, that would be bearing 180 degrees. Okay, that would be all the way down here. Does that make sense?
Yes.
Okay. Not a big deal. Just make sure that you know what bearings are. You will have to be able to understand the picture, what we're looking at. So what you have here is you have two boats, one bearing 42 degrees, 30 minutes, the other bearing 52 degrees, 12 minutes. The question asks us, how far are the boats apart when they're both 25 miles away from port? So you can see the red X on the screen. That's what we're looking to find. How far are they apart? Notice that's on an arc. So what formula do you think is most relevant for this? Good. S equals R theta. And what do we have to remember about theta? Okay, radians. Okay, or AD. Okay, not R, ED. In radians, theta is always in radians here. Which means I have to do two things. I've got to convert my angle measurements into radians. Go for it. Okay, so when you convert radians to degrees, or not to radians, but when you convert degrees and minutes into degrees, we have 30 minutes out of 60 minutes. That's half a radian. So you add them together. The second angle, 52 degrees plus 12 over 60 equals 52 what? 52, what's the decimal? Good, 0.2. It is really, really important that you do this for yourself. You check to see what I'm doing. You do this before. When I give you time to work it out, you do it before. You don't wait for me to do it. You use my work to confirm your ideas. Or that when you get home tonight and you just copied it, you won't be any better off, even though I explained it to you. You need to do it for yourself now and use my work to confirm what you think is right and correct your mistakes. Okay? What's the next step? We've got degrees, but I need radians. Good. We multiply by our conversion to radians. We multiply that through. Take a minute. I want you to multiply and see if you get your radians. Alright, so let's make sure we got them all right. So the radian measure for this is what? Go to 4 places. 7, 4 what? 417. Good. 0.7418. The radian measure for this one should be 0.9111. Does everybody confirm that?
Yes.
Good. So let's back up a minute and talk about what the problem's asking me to do. what you have here is I've got a big arc and I have a smaller arc, but I want what's in between the two arcs. So what are we going to have to do to find out the distance between the boats? Find the big one, find the smaller one, and then do what? Subtract the two. That's exactly the process that needs to happen. I want the difference in the two arcs. So I have to know the arcs, the lengths, and then once I have the length, then I can subtract the larger from the smaller, or the smaller from the larger, and get the difference in the two arcs. So let's go ahead and set up the arc measures. So S equals R theta. R is 25. The theta, we found two of those over there, 0.7418. And then we have S, we'll call that 1, and this 2, equals 25 times 0.9111. And those give me the two arcs. Let's go ahead and compute the two arcs, find the difference, and see if you get it right. Okay, so you can see the solution here. We multiplied through, we found our smaller arc, we found our larger arc, then we subtracted the two. The distance between the two boats would be 4.23 miles. How do we know it's in miles, by the way? The problem, you didn't know this, the problem itself started off and the radius was in miles. So we didn't convert any units. So the distance, the physical distances are all in miles. Whatever, if your units start off in something and you don't convert them, they stay the same units. Alright, the next problem, I'm going to let you work with this one to start with. I've given you the formulas that are relevant. The problem, we kind of explained it to you. You have a lady that rides her bike, okay? Her spokes are 13 inches, so the radius of her bicycle wheel is 13 inches. She currently is riding at a velocity, a linear velocity of 44 feet per second. The question is, how fast is she traveling in radians per second? How fast are her wheels spinning in terms of, not radians, but revolutions per minute? So what I need from you to find out is revolutions per minute. That's the radius of your wheel. So go ahead and find out how many revolutions per minute are her wheels spinning. No. So here's what we're going to do. We know that we have linear velocity. That's 44 feet per second. That's equal to the radius of the wheel, right? We went ahead and said, well, 13 divided by 12 would be 1.08 feet. So we have 1.08 because we needed to make sure that all the measurements of distance are in the same unit. The formula doesn't know the difference if I have different units. It automatically assumes that all the units are exactly the same. So make sure that when you plug stuff in, they're all in the same units. 12 inches and 1 foot. So I have 13 inches. How many feet is that? Well, it's a little bit more than 1 foot, right? Because it's 13. So I have basically 1 foot and 1 inch. So that's where this comes from. Okay, times theta divided by time. And here's where the logic comes in. What is that? What is this? Revolutions per minute. But okay, back up a minute. Is that a linear speed or is that an angular speed? Am I going around in circles or am I walking in a straight line? It would be circular, right? So I need to convert the angular speed into revolutions per minute. Well, what's angular speed? Whatever theta divided by t is, that's angular speed. What can I do to this to make it equal to theta over t? Good. That allows me to say 40.74, okay, equals theta divided by time. So what units is this? That's a big deal, by the way. What units is my theta going to automatically be into? Radians per second. Good. How do I know it's radians per second? Well, first of all, let's do the seconds. It was in seconds to start with. I haven't converted it to another time frame yet. It's still in seconds. How do we know that the theta we're looking at is in radians? Listen. Because I told you last week, this formula always uses radians. So it doesn't matter. When you find theta or theta over time, whatever, your results will automatically be in radians. If you want it in degrees, you have to convert it into degrees later. So it's automatically radians per second. So let's bring that over here. We have 40.74 radians per second. What do we want?
Radians per minute.
We want what?
Revolution.
We want revolutions per minute. Let's take care of the time. How can I get rid of seconds?
Crossing it out.
Yeah, let's just mark it off. We don't have to do anything else, right? So how many seconds are in 1 minute?
60, so you divide it by 60.
No, you multiply by 60. Just put that up. iPad should be off. Okay, it's fine. It's fine. I'm not done yet. Now I'm in radians per minute. Shh. I'm in radians per minute. Still not finished. Okay? I want to end up with revolutions on the top. So, revolutions over, I need to get rid of radians. So what number goes with those? 180. I mean, I could put 180. Oh, that's a degree measure, and I don't have any degrees here. 2 pi goes where? How many revolutions is that?
1.
A full revolution around my circle is exactly one revolution is 2 pi. One full revolution is also 360 degrees. If I needed to convert this to degrees, I would be using 360 there. It didn't ask me for that. Okay? I don't need degrees because I'm in radians. Since I'm starting in radians, I need to cancel out with radians. To get my result, listen, it's going to be 40.74 times 60 divided by 2 pi. I want you to actually do this in your calculator because half of you are about to make one of the biggest mistakes that these problems have. Those of you that come out with several thousands as an answer, you just typed it in wrong. Do it real quick and see what you get.
Several thousands or 80,000?
Any thousands. Listen. Shh. This will get you the answer marked wrong, but you actually did everything properly. Shh. Watch. If you have a calculator that allows you to type in fraction form, then it saves you from that. But in a traditional calculator, even in one of these, if I'm not using the fraction version, I'm just typing it in, you're going to have this up top divided by with a slash and then 2 pi. That is all the most critical. Because if you don't put the parentheses in, what it does is it divides by 2 first. And then it multiplies the pi on top. If you ever have a fraction, whatever goes in the denominator, you need to put in parentheses. If you don't, it doesn't know that it's in the bottom of the fraction. In fact, whenever you use a situation like this where you have several things, it's best to either use the fraction mode if you have it, or put everything on the top in parentheses, everything in the bottom in parentheses. Okay? So, she's making 389.04 revolutions per minute if she's traveling at 44 feet per second on a 13-inch radius for a wheel. Questions? Okay. Let's go on to the next problem. This is actually fairly easy. I'm going to give you a minute. What we have here is 54. This is problem number 54. Okay. You have a pendulum. That pendulum swings. The Smithsonian has a very large pendulum that swings on a 52-foot cord. Listen. Okay, this is a big pendulum ball that swings back and forth. If that pendulum swings just 1 degree, how far has the ball actually traveled along its arc here? Find that. Number 54. Quiet, please. My R value, my radius, is 52. My theta is 1 degree. It's asking for a length along an arc. So arc length is the formula that we're going to use. S equals R theta. We really only have 3 formulas. Arc length, linear velocity, and angular velocity. Those are the 3 formulas we've been sticking to the whole time. Okay? What am I going to have to do first?
You have to make a radian.
Got to convert to radians. So let's multiply pi over 180. Okay, that's going to give me point, what is it, 0.17 something?
0.1453293.
No, that's too small.
0.175.
Yeah. That's what I thought that was. 0.175. Thought that's what it was. Shh, quiet, please. So 0.0175 you round to 4 places. We take that. We say 52 times 0.0175. .91 feet. There is absolutely no excuse for anyone in this room not to be able to get that. It was about plain as it gets formula for arc length.